All right, where are my cameras? All right, Mark Hughes, broadcast lens. We're doing independent isolated output recording, live take. And for those of you joining early, I am just online right now to make sure that everything is connected and working and that I can run my switchers in a decent enough manner. We're not actually doing the teardown for another 2 minutes. But if you're out there, viewing audience, feel free to let me know how the audio sounds in the chat. I'm just making sure I've got everything ready to go as much as possible. This is the most involved that I have ever done a video. So we are on camera 1. I can cue camera 2. And then camera 6. So it looks like we're ready to go. If anybody's out there in TV land and you don't mind letting me know how the audio's doing. Oh, we got Andrew. Andrew, welcome around, man. How's life back at work with the kid? How's work-life balance treating you? Crackling from clothing. It could be the mic placement. Let me bring it out ever so slightly, and that might help it. I also noticed the mic was extra hot, so I turned it down as much as possible. But the amount of technology that I've got going right now and the number of ways that it can go wrong is just truly astounding. It's pretty special. Okay, so yeah, camera 6, the in-screen display. Let me turn that off. Thank you, by the way, if I can. Let me bring it up here. And see what we can do, since we have a minute. Oh, what did I get myself into? That's the histograms and everything, which are wonderful. I have no idea how to turn these off. Object targeting failed. Oh, well, that's a nifty feature, but I don't want to use that. Andrew, I'm going to tell you, it's not a flaw, it's a feature, buddy. I don't know how to turn this off. Ha ha ha. Holding it down does nothing. And I can't drag it out of the way. We'll just have to pick the well, that is frustrating, isn't it? Yeah, I just gonna have to go with the least annoying one. I have no idea how to turn that feature off. And it's actually a feature that would be totally useful on my other monitor, but you know, what are you gonna do? So it's gonna get hot. Can already feel it. Let's see if I can turn down this light a little. All right, it is about that time. let's get this party started, huh? Welcome everyone to Mark Voids a Warranty. My name's Mark. This is the Warranty Voider. It's a nice little drilling hammer, 2 or 3 pounds. You gotta love it. Anyways, thank you all for joining me today. It's gonna be a fun one. I promised you as soon as we got to 500 subscribers, I was gonna do this lens. And guess what? It's time. We got to, I don't know where we're at right now. It's like 640 or something around there. Thanks to Mark Harris of the Altium, the Celestial Altium Library. That's what it's called. So it should be fun. I've got all sorts of technology going. I've got lighting today that I usually never use. I've got cameras that I never use. You know, we've got the one we're looking at now. I've got my typical setup, and then I've also got a camera looking down here. So when we get to interesting stuff on the workbench, you know, hopefully we'll be able to look at it. This is the Canon J40 X9.5B lens. When this thing was new, I'm sure it was expensive. It's got an incredible focal length range of 9.5 to 380 millimeters. With an f1.2 lens. Check out the size of that thing. It's pretty incredible. As we go through this, something on the hamburger menu in the upper right. Andrew, I really have no idea what you're talking about on that one. That must be with camera 6. Anyhow, as we go through this, if you have comments, please feel free to ask them. It should be fun. I haven't really done anything to this lens. I haven't inspected how to take it apart. I haven't really done much research. Well, I tried researching it. I couldn't find any info on it. All I found were links that took me back to me. So if you know anything about these lenses, let me know. Right now, I'm just trying to get the this little shroud off so I can show you the true diameter of this thing. And there are little spring releases, there we go, that are really hard on the fingers. They could have put a knob up there for me, I'll tell you. Okay, come on. Sorry to walk in front of you there, but I've made my fingers mad at me. I have to change the other hand. There we go. All right, so this is just a little sun shield that goes on the front of the thing to block light from blasting across the sides of it. But that is an absolutely ginormous lens. You just don't see stuff like that out in real life. I mean, you're lucky. You're lucky to get a lens that's this big. You know, and these things are really amazing. I mean, if you think about it, this is going to be a little philosophical, but you're watching me in the past, right? It takes some amount of time for the light, you know, the photons that leave me to reach the lens, to go through the computer and to see it. So everything that you're seeing happened, you know, 30 seconds ago. And we figured out as scientists, as engineers, how to do that, how to even slow things down even more. And if you slow the information down in selective ways, you can bend and you can warp it. And that's pretty amazing. You know, that's really what lenses do. You know, they've got these little profiles. I don't know if we'll be able to see that or not. But light that goes through here gets slowed down selectively. And, you know, we can bend it and we can modify it. And we can give me a big nose. And at some point, too, we learned how to do the same thing with just changing the shape and angles of things with Fresnel lenses. I don't know. It's all pretty neat. So let's get going here. This little sunshade doesn't excite me. So we'll set that off to the side. And then we've got to figure out how to get this big case open. And I don't really know how to do that just yet. There are a couple... I mean, it looks like it's damaged slightly to me. There's a couple of bent spots here where it looks like there could have been some case screws. You guys might be able to see those. I can hear a little bit of rattling, but that just seems to be the lens floating inside of its case. So let's... Oh. little anticlimactic. It just slid right off. So I'm guessing those screws were meant to hold that thing in. So now we've got our first look inside this thing, and it might be a little difficult for you guys to see from that far away. So I'll switch to camera 6 here in just a second. But I'll give you a chance to take a look at everything that's going on inside of here. Neat, neat, neat. This is going to be so much fun. Let's see if I can't pull up camera 6 for you. All right, so this is a top-down view of the lens that I'm going to try to get in a little bit closer. And, oh my goodness, this thing is not light. Not light at all. So we've got a big black control box. I don't really know what's in that yet. You've got a wide assortment of electronics in that thing. All sorts of adjustments and, whoop, wrong way. There we go. All sorts of adjustments. You know, you've got wires that are coming out. Let's see if I can zoom out a little here for you. There we go. All sorts of wires, you know, red, green, blue. So that's got to be something. You've got all sorts of colored, I mean, a really well put together wire harness. Over here, we've got something that looks like it's a bit of a heater lamp. It looks like it might be a tally light lamp. Iris control. On the bottom, man, this thing really is heavy. Flexible module. I really don't know what these things are, but let's unscrew them. That one snapped when I did that. Feels like it should just come out, but it doesn't. There it goes. So we've got some sort of a, this looks like a mechanical module. I'm not entirely sure what this does. Let's see if we can get the other one out too. Come on. There we go. So it looks like these might be modular, like you could replace this, you know, maybe you put in a wire that you twist around and it controls something. Or maybe you could have this replaced with a electromechanical version of it. So either way, I don't know, but we're going to learn as we go. So let's get back to Cam 1 and we'll take a look. Absolutely fascinating stuff so far. Oh, Andrew's got to log out. I'm sorry, Andrew. We're going to miss you, buddy. So anyhow, a whole lot to go on here. There's a heater. My suspicion is you get it at some point, you get to a temperature where moisture can start condensing on that lens. And that is their way around it. So join me as we start to just take stuff apart. I got to tell you, this is a big lens. These things are expensive. We might be together for a minute or two. All right. One of the reasons that I like taking this stuff apart is you learn stuff. You learn what other engineers have done. Only difference between an expert and an amateur is the expert has learned solutions to problems that the amateur doesn't know exist yet. And that is really all there is to it. You know, you get into a field and you meet somebody and, you know, it's like, oh man, that guy's a genius. Well, true genius is few and far between. There's just not as many of them out there as people like to think there are. Mostly it's hard work. Sitting around, learning stuff, experimenting with stuff, making mistakes, fixing those mistakes. And then eventually you just get somebody who's just been in the room long enough that they've seen all these things that are, you know, it looks like magic to you. I'll give you an example. Cal State Fullerton is where I got my degree at in physics. And I went back a couple, you know, this is just right before COVID, for a preliminary design review and a cumulative design review for the Cal State Fullerton Titan rover. These kids have to make a model robot that can go do things on Mars. Now, they don't actually send it to Mars. That would be kind of crazy. But they take it out to the Utah desert and, you know, they do rock samples and all sorts of fun stuff like that. Now, I show up and these poor kids, you know, it's their first time ever doing anything where they're going to be judged by professionals. And, you know, they're a little scared and, you know, they make rookie mistakes. Everybody does. Whoops. Well, that bulb is out. But they start telling me what they're doing, and they start showing me some of the things that they've got going on. And, you know, one kid's using IMU, and in this case, it's the Bosch B&O 055. Well, that particular IMU I know quite a bit about. So he's walking through how he's going to use this thing, and I start asking questions that are just incredibly technical and incredibly specific, not just to IMUs in general, but to this particular IMU. And, you know, he's taken aback a little bit, and he doesn't know quite what's going on. And, you know, I try to walk him through it. I don't pick on him too much. I pick on him a little because, well, I'm me. But it's not too bad. And he asks, you know, questions, and he, you know, we talk after and all that. And then the next guy comes up, you know, and he's talking about creating a terminal node controller for backup communication. Well, I'm a ham. Amateur radio operator, Kilo Echo 6 Whiskey Oscar Bravo. I know a little bit about TNCs. So, you know, I'm asking him questions about his plan and his setup. And, you know, the same thing happens. You know, 2, 3, 4, 5 people deep. And these are all highly specific things that they're talking about in their design review. And I don't know a whole lot. But it just so happens, just through dumb luck, I know quite a bit about everything that these guys are talking about, right? They could have picked other IMUs, you know, they could have picked other cameras, they could have picked other microcontrollers, but everything that they are using, they're all things I know. So to them, I must have looked like a god, and I'm far from it. But the only difference is, between them and me, is I learned about that stuff before they did. I wasn't born knowing those things. All right. We have removed a lot off of this heater plate. It looks like there's some glue holding it in. I don't know how much deeper I can get into that. So we're going to move on. We're looking at the bottom of the lens right now, and all I'm doing right now is just taking out screws. There are more exciting things to do in life, but it's got to be done. And if you don't mind, as you guys join me, it is getting quite warm in here with the fan off. I am going to remove this heavy lab coat. Man, that'll keep you warm in winter, but we're in the mid-70s in here, and that's hot. All right, this is the bottom plate for the lens. There's a large 3/8/16 mount, so this is one of the things that they can use to support the lens. And again, I'm just moving myself around, taking things off. If you have any questions as we go, please let me know. If not, I will talk and pontificate as I get screws off. There's a lot of electromechanical integration in these things, and we'll get to that as I start getting deeper into the lens. But I mean, you'd have had a lot of collaboration with the mechanical team that designed the optics on this and the electronics team that designed everything else. They would have had to been good friends. This is not a simple design. So on the left side of the lens, you know, you can see a few things, and I might actually be better going to camera 6 here. Let's see. That should give you a better view. Sorry for that little mess in the corner there. So this is the bottom there, and you can kind of start making out some things. There's some connectors down here. I don't know what all you can see. It looks like you can't see it just yet, so we might have to wait until we get a little deeper in here, get a few more things removed. There are interesting things, though. Let me see if I can swing right. You know, some really high-density pinned circular connectors. Other electromechanical things. Looks like we're going to have to just be patient and keep taking stuff apart, huh? Let's see if I can move this mechanically one way or the other. There we go. All right. So I don't know what this is, but it looks like it might be electromechanical in nature. We've got 3 what almost looks like sealed coaxial connectors. I don't know, but we're going to find out. If you know. Let's see, no new comments yet, but if you do know and you're watching, please feel free to ask. There's a good chance you'll know more about this thing than me. Interestingly, and I don't know why, but this is really heavy duty. A lot in this stuff looks like it can be aligned. Whoops. I don't know. Oh yeah, that totally moves this. So let's see, what can you see? Let's zoom in a little. So this maybe has something to do with the zoom. So this adjustment twists whatever that thing is, it rolls it, and this moves it in and out. I wouldn't be surprised if this doesn't end up being some sort of a focus mechanism. So here's what was on the back side of that. So when I was twisting those, it's a little cam that slides around. See? Interesting, interesting. Looks like we're going to need quite a bit more breakdown to get to that. All right. We're going to keep breaking down. We've got a little barrier block that they used to make connections here. We've got some wire mounts that connect things to the optical path. You know, some, make sure I'm on screen here, a connector here. I'm still trying to work my way towards that thing. It looks like we're going to have to take it off. I mean, I am just guessing here, but this, to me, it would make sense if this was some sort of a part of the lens that deals with focus. Of course, I could be wrong. I don't know. I don't know if the focus is controlled in the camera and not the lens. Okay, there we go. This part is free, so we've got something interesting. Man, I don't know what I'm looking at, but it looks cool. All right, we'll get this over to the workbench in a minute and give it a proper look. I bet you that's a focus something. But whatever it is now free. We've got an iris control. An iris controls the amount of light that gets into the lens. It closes down an aperture. Looks like I've got to unplug this. Make sure I'm on screen here. So this is the iris control. And we've got a motor that, oh, check that out. Okay, this is interesting. Where's my finger? There's a little display here that shows through, and it shows you what the aperture is. That's neat. Neat, neat, neat. Okay. So let's get these boards off. So these... Hi, Chester. So these boards in the back here have connectors to those two things I just dismantled. One is the iris control, so it looks like it controls the motor. And then the other, am I on screen here? This is the one that connected to that thing that I might think is focus control. But I'm not sure. Okay, so these are little, I mean, these are old school boards. These things were laid out by hand. I can just tell that by the way these things look. So these will be fun to look at under the microscope. We've got some posts that look like they're maybe test points. I don't know, but we're gonna find out. So we'll keep digging. All right, we've got a wire barrier block with all these wires connected. I'm going to go ahead and disconnect all those while I'm here. Man, absolutely fascinating. Again, for those of you out there in TV land that are watching, I'm on camera 6 right now, which is a portable top-down view. Of this giant broadcast lens. Okay, so right now I'm just kind of working my way around, taking things apart as they appear to me. We found a module that looks like it's a focus module that we're going to pull out. Let me make sure I'm on screen here. Right now I'm just kind of, if I see a screw, I take out the screw. There's no real rhyme or reason to my particular methodology at the moment. But that is a clean looking harness, I tell you. All right, so over on this side, we've got a, more connections for that heater blanket that heats the lens assembly that presumably keeps condensation from forming on it. It's a big heater blanket, so that must not take much time to get going. All right. It's glued down. It'll take a little extra work to get that off. All right, we're going to keep going. Oh, it's telling me that movie recording has stopped. I don't know if I believe that. Do you folks? There we go. We're recording again. So we've got a ground connection here. That's gone. All right, so we are at the top of the lens, and there are more shrouds, and there's a lot of screws in this thing. Putting this together must have just been a nightmare. See if I can get this light bulb out without breaking it. Maybe not. I don't know. Come on, guy. You know you want to. You know you don't want to be there. Come on. Nope. Okay, be that way. If you break, then it's on you. I tried to save you. This is a tally light that lets somebody know that the camera is live. Okay, that's free. Boy, man, this is a teardown. This thing is built like a tank. Again, the plan of attack right now is just attack. If I see a screw, the screw goes. That one's just spinning. Must be a nut on the other side. Okay. What can you see? So this is the front of the lens. There's just a little metal shroud here that I am demolishing. This was built back in the day before CAD programs existed. So whoever made this, every bend and tilt and turn, all of that had to be thought out in your head and then drawn on paper. It must have been quite the undertaking. All right, let's head back to camera 2 for a minute and get an idea of what it is that we're doing. We're taking apart this lens. Right now, I've taken off the giant metal shroud that held everything together, and I'm going after all the screws and whatnot. This is the front of the lens, you know, where the main light comes in. We've got a shroud that I just took off, which is an interesting helical coil. I don't know exactly what all that is yet. And then we've got this thing, which I'm not entirely sure what it is, but there's a good chance, I don't know if you guys can see the light coming in on that. There's a good chance this has something to do with focus or aperture. I mean, I don't know. We'll take it apart and see what there is to see. We've taken apart everything that holds the heater on, except the heater element is glued on the front, so I can't do much about that. It's one of those things where there's just so many places you could start. It's hard to know where to. I'm trying to get to the point where I can have access to these older boards and we can see what they're doing. You know what they do. But there is so much in here to tackle. Come on. Nope, gonna have to need an actual screwdriver. Boy, I tell you, this thing's old. I love it. You know, some of these newer lenses, they're a couple $100,000. They're crazy. I don't really have a good idea how much this one costs. I paid 50 bucks for it, which I knew was a steal. I got it in Burbank at this surpluser called Apex Electronics. And for 50 bucks, I'm happy. Okay, that part's loose. There's a second big screw down there I missed. Come on. Come on, little guy. We both know how this ends. You're coming out of there. And either it's the easy way or the hard way. There we go. I mean, that thing is solid. I don't know if you guys can see that or not, but, you know, we've got a little brush DC motor. I mean, everything here is custom. You've got a brass carrier for this gear. And it is just, I'm not on screen, but man, it is just smooth as silk. I don't even know how to describe it. It's just, it's well built. You can't even feel the gear teeth engaging. All right, so we've got some Allen keys there. We still have this wire harness to get to. Looks like it's time to move to Allen's. Okay. As we go through again, if you do have any questions, please do ask. I'm more than happy to answer them as we go. This one's going to be probably too big. Yeah, by a lot. I am trying to monitor chat a little. Still way too big. What am I doing? Let's go down to 3/32 and see what happens. There we go. Uh-oh. That's not good. Yeah, I can't twist them with these. I'm going to break the tool. We need a plan B. Or a plan C. Okay. So that tiny little thing was a 3/32. If my thing was, oh, is it smaller than that? It's going to be smaller than that. Might have to go metric. I don't know. We'll see. There it goes. Uh-oh, come on. These things are in tight. See if I can break it free. I don't know. It's not looking good. Might need an impact tool. No, don't do that to me. Nope. Let me see if I can get a little more purchase with a 2. Nothing. These things are not budging. So they were either torqued in or there's some thread lock on them. There we go. Okay, I broke one loose. Let's keep trying. This is a large helical connector here. Come on. There we go. Yay! All right, so we got these two loose. Now, if you have any ideas on how to make mark voids of warranty a little more interesting, I'd be happy to hear them. This one's obviously going to take a little longer than usual just because of the size of the project, but we can always edit it down. Come on. There we go. Okay. So this is the bad boy that I've been working on, and this does something with the lens control. You know, we've got a cam that follows around in these grooves and does something. But all of this stuff was custom made. It's very cool. So there's the cam. Looks like it was broken off and it's stuck in the groove there. I don't think it's supposed to be that way. But interesting, interesting. Okay, so inside there is a, what are we looking at here? Where are you guys? We're not looking at anything useful. Let's get back to cam 6. I am recording everything here. And the purpose of that is if I am off screen on something, I can always change and give y'all a better view in the replay. Okay, I want to show you this. So I need to rotate things. So that spiral we just looked at, where is, sorry, I'm still trying to get what I want to show you on screen. Nope, wrong hand. Haha. Silly me. There we go. That's a little better. So that helix that I just took out, that went right here. And hiding underneath it is a big fat piece of brass that moves a lens element in a straight line. That's this thing right here. So that fit inside that helix, and once we start getting into the lens parts, we'll see what that thing did. But anyhow, that's that. Let's keep getting to our circuit boards. Oh. My goodness. Theoretically, this thing's getting lighter, but I tell you, it just doesn't feel that way. So we've got a couple pieces of plastic. I don't know if it's Delrin or Teflon or what. And they just look like they're slides for something. We are now at the top of the lens. There are some ventilation holes here, but nothing too darn exciting. You can hear some of my handiwork coming apart as things slide around. I'm not too good about picking up my screws right now. All right. So on the top of this thing, it says, warning, high voltage. What do you think? Should I pay attention, Internet? Or do you want to see me hurt myself? You sadists. So I need a screwdriver that will fit. Uh-oh, and I just dropped it underneath my workbench. Well, that wasn't smart. Let's see if my Leatherman will do. Yeah, it will. I know camera 6 kind of a weird view. I'm actually streaming it through my phone. Was the way I was able to get that to work. Okay. Warning, high voltage. Attention, hot tension. Okay, so that module's free. It's got a custom connector on the bottom of it. Let's get that on screen there if I can. So those long screws just pass all the way through to a, I mean, I don't know who makes that, but just by looking at it, I can tell you that thing is expensive. Let's see if we can't liberate it. Not with that screwdriver. I tell you, I hope you guys are enjoying Mark Void's Warranty today. This is by far the largest thing we've ever taken apart. Am I looking at those? Oh, I'm not. Okay, I am looking at the wrong thing. Trying to put a screwdriver into a rivet doesn't work. Still tell you, that is a nice looking wire harness. We have what appears to be, I mean, it could be a sensor of some sort, or it could just be a transistor that they're using the body of the lens to sink the heat into. Okay, let's see if we can't keep getting these things out. Too bad this is called Mark Voids a Warranty and not Mark Eats a Hamburger. Mark's getting hungry. Tell you, once this project's done, we're going to have Mark refinishes his bench top, because we have scratched the heck out of this thing. All these sharp corners. Okay. One shroud down. Still trying to work my way around to free these things. And it's not immediately clear to me how all that happens. There's bigger screws and smaller screws and smaller screws and bigger screws. The big ones seem to go through things all the way down to the lens body. So that might be the secret to removing this panel. This is a strictly mechanical panel where we had the focus and zoom mechanical connectors on. Looks like they were provided with electronic connectors that weren't used, so they were probably given as upgrades. Okay, what do we have here? Is that coming off? Hi, Chester. Surprised we haven't had Phat Ollie join us yet. Hi, buddy. I know. Okay, come on, guy. Off you go. Let's check in on you, buddy. You just need a quick scratch. Okay. One more panel down, and probably time for a camera switch. and a quick break from Mark. While we're taking our quick break, let me introduce you to Mr. Chester. Chester is a kitty that's been on this earth for quite some time. He came to me in 2004 as a rescue. I've rescued quite a few kitties in my time, but Chester is probably the one that's been with me the longest. Also a rescue from my foster days, we have Phat Ollie. Phat Ollie is a good kitty. He doesn't like being held though, so he's going back down. All right, let's continue. If we weren't having fun before, we are now. All right, looks like I'm on camera too. So the next thing I'm going to try to tackle, I'm still trying to free this wire harness. We've got these connectors to the zoom and focus lenses. I'm going to guess it's a 3. I'm probably going to be wrong. I am. That's way too big. Let's try a 2. It's going to be too small. So I need something in between. There we go. So that is a 3/32. Let me get that out of something that's a little easier to work with, these small guys. But again, I am just taken aback by the amount of engineering that this must have required, especially in the days pre-CAD. I mean, so many different facets of engineering. This lens body that everything's mounted to would have had to been cast and then later milled. Everything that you see, every part that you see is an expense. You've got to do whatever machine steps and processes are required to it. You know, if you're milling it, if you're bending, cutting, everything takes time. Everything is an expense. And they had to figure all this out pre-CAD. That's the part that's blowing me away right now. Everything here has feedback. Everything is a servo drive. There's, you know, when you have a gear, there's a potentiometer on it. Get rid of that. Okay, let's get back to your favorite and mine, camera 6. Let me also start and stop recording. The movie I recorded was split into multiple files. It exceeded the file limit. I imagine that it did. All right, so these gears all control focus and whatnot, and I wish I could tell you how smooth these things go. I mean, you can barely hear anything. You can barely hear the gears connecting and disconnecting. So this must be a fancy rotary encoder. It's got 3 outputs, so it's quadrature maybe. Everything is, are they just wire? Or no, they're soldered on. They did a good job. So I've got to get those off, and I'm probably just going to have to cut them. To free up the harness there. Yeah, let's do that. We don't have all day, but we do need a cutter. Where are my cutters? Oh, here we go. I had them prepared. Who does that? Okay. free as the wind blows. All right, what do we do next, people? What do we do next? All right, we are now in the mode of, if we see a screw, we take out the screw. We've got another, what appears to be an encoder on the iris here. And we might as well, I mean, since we're cutting it, we can cut it wherever we want. Might as well do that. All right, I still want this big block free. That's where all of the fun circuit boards are. I don't want to destroy that beautiful wire harness to do it. There's a lot to learn there too. So tell you what I'll do. Let's come over to this side. And let's flip this. Okay. Whoop. There I am. No, there's the computer. All right, so here is our lens body. And I am just looking for and removing screws. A lot of these are for the wire harness. They are non-structural. But man, they did such a clean job. Such a clean job. All right, we've got another one of these little motor control boards. And all they are just looks like reservoir caps and then an expensive connector. I don't know what those things are, but they're nice. Now we've got another big fat motor. More wire harness screws that I'm going to spend a year finding on my office floor. Thank goodness it's wood, so I can sweep it. Okay. So this is either a sensor or a motor. It looks like it's a motor. And it feels geared. But if I don't know if you guys can see on camera, but if I spin any of these things, they just keep spinning. And that's true for any of the gear trains, any of the motors. I mean, everything is just so beautifully done. Almost criminal what I'm doing to this. Thank goodness I'm a professional. Nope, that's not moving at all. One of the things I like, one of the tools I like, and you might like them too. If you ever have a screw that you just can't move, you get these pliers. They're called van pliers. And the nice thing about them is they have threads at the top cut so that they can grab screws. They come in different sizes. And I might have to get the bigger pair out. But they let you grab screws on end. Or from the side. So if you have something that's really cranked in there, is it going to work? Nope. Let's get the bigger ones out. Oh boy. These ones are not playing nice. These are very soft screws. And they're really in there. I think all I'm doing is damaging them. We might even have to Dremel these. Is that one moving? That one's finally moving. Let's see if we can't get that other one moving. Yep, it's moving. Let's hope it was just those two. Nope, there's something else down there that I can't see. Hi, Chester. Okay. So there's that, and that one appears to be a quadrature encoder. Come on, Chester. Come on, baby. You can do it. Jump up. Uh-oh. Uh-oh. There we go. So we've got another quadrature encoder on a gear. So that's doing something. A lot of sensors in this thing. All of that would have had to go back to this central controller that we are trying desperately to get to. This looks like it might be another one of these types of nice connectors. Wish I knew what they were. There we go. Is that a 5.5? It feels like it's slipping. It doesn't feel like it's catching. What was that? It's not. That's a 5. Let's go slightly. No, that's a 5.5. Oh, there we go. It's 3/16. We had to go imperial. Whoa, look at that. That is a connector, let me tell you. I don't know what that thing's called, but I can promise you it's expensive. Wow. That is neat. Okay, how do we get... Looks like you have to shift it to move the rest. Oh, are we not recording? Let's see. What's going on? Let's look. Do we have another view? I hope camera 6 is recording. Oh no, I don't want that. Go away. Now we're recording again. Sorry about that, internet. We'll have to figure that out. What I was trying to show you a minute ago before I was watching my screen there is this cool connector. I don't know what it is, but I've seen similar things at trade shows and they are not cheap. Not at all, but that's how they're connecting the wire harness around. Just need to get in there and take this thing apart. I don't even know what I'm unscrewing. Hopefully this releases the harness, but it doesn't feel like it. Maybe there's some bolts on the back side. Yep, bolts on the back side. Come on. Come on, little guy. Okay, so that is our harness, and our harness connection is now free. That alone must have been a pretty penny. If any of you out there know how much those things cost, let me know. I would be interested to know. All right. Let's get back to camera 2 for a second. We have to be an hour in by now. This has been a long teardown. But man, are we having fun. We found all sorts of cool stuff that we will eventually get around to looking at under the microscope. But I'm still taking this lens apart, and we're going to keep doing that. So what we have so far, front of the lens is towards me. It is right side up at the moment. I can't actually see my screen. Give me a second here, and I can make an adjustment for you. Okay. So front of the lens is over here. Back of the lens is here. Right now, I've just been taking apart the wire harness. I'm trying to get to this box up front that's facing you. This houses all of the electronics for the system. This is actually what I want to look at. But so far, it's just been a lot of tedious teardown. It could be, now that I can see a little clearer, there are some vent holes on the front here. And I bet those vent holes are screw holes. I wonder if I put a Phillips in there, what happens. You might hear the occasional click and clomp as screws and whatnot fall off my poor workbench. It's taken a beating on this one. Okay, it doesn't feel like Phillips. It doesn't feel like flat. They were using a 3/32 pretty frequently through this build, so I'm going to see if maybe it's that. If not, we're going to have to get a peek in those holes. It doesn't feel like it's connecting with anything. All right, we need to see inside. Guessing isn't working for me. So let's see if I have a flashlight on me. Nope. I was wrong. There's nothing in there that looks like a screw. That's why it wasn't connecting. There are, though, I didn't see these before. There are these really tiny Phillips heads on the front there. So maybe... Nope, that's too big. What is my smallest Phillips? So maybe after we take these apart, that lid will come off. And then maybe once that lid's off, we can take a look at that board, get it out. And then maybe we can free up those circuit boards. That one doesn't want to spin. These are tiny, tiny, tiny little screws. I don't even know what size they are, but they are not big. Let's see if I have another look. I don't. Whenever I can't figure out how to take something apart, one of my go-to tricks is take apart every screw that you can find. Sometimes that's the trick. Sometimes it makes life worse. Okay, but this feels like we're actually maybe getting lucky. What's left? What's missing? These things are recessed. They're hard to see. I could be missing them. I wouldn't even know. Nope. Woohoo! Finally! Some measure of success. Okay. Whoop. I need a remote where I can just, or an if then that, just say camera 6 and have it switch. So here are our first looks at the board assemblies. So we've got edge connectors. Let's see if I can zero in on a little. So we've got edge connectors that are connecting up the wire harness. Same type of thing you'd see in an old school PCB, old school computer. And then you've got risers that hold everything in. I don't know how those are connected just yet. There's a little switch mount for a test. Do these just slide out? They just slide out. Oh, that's cute. So these things, you just pull them. Nice. I guess you would need to know where which one goes. Okay. We're making a little bit of progress again. The technicians who had to learn how to work on these, man, and assemble them. My goodness. The process engineering that had to go into all that. Forget it. I mean, I wonder how big these teams were that had to work on these. Okay, we do see some damage, not caused by me. Let's see if I can get that visible to you. All looks pretty dark on my end. See right there, this edge connector? If not, I'll show it to you when we get to the, when we get further into the teardown, I'll show it to you. Okay. Wire harness is free. Free as the wind. All right. So we're starting to, I mean, we're still working on it. We're still freeing up this body, but we have boards now. Guess I can show those on camera 2 for you. So we've got these little guys. All would have been hand routed. This is all Okay, audio's finally back. How long ago did that happen, Alex? No. Okay, but I've got audio back. Thank you for that, buddy. We'll figure it out. There's going to be more than enough here for you. But thank you for that. All right, so still taking apart the body of this thing. Wondering how long ago I lost sound. This should take off the backing plate, I hope. Yep. So this is the part that mounted to the camera. Big heavy piece of aluminum. It's the batteries. Okay, now I've got audio again. I hope. Alex, keep me honest. So I just took off the backing plate there. In our marathon teardown, I don't think we've ever taken anything apart that is this intense. We haven't even really gotten to examine any boards yet, just because we've spent so much time dismantling this thing. We've got to find a way too, Alex, so that if I do lose sound or something like that, and you need to send me an emergency message, you can. But I don't know how that's going to work. The audio is all one way. All right, so on the back of the lens, there is a bayonet mount. And that is what I'm going after right now. My hope is that I can start getting these giant lens elements free. Okay, so there's two brass-looking shims or gaskets, I don't really know. And I'm going to just keep going. So the bayonet mount is free. Camera 6 is complaining I recorded up the whole card. Kind of sounds like I need a bigger card, don't you think? Something's happening there. All right. Hi, Chester. What's wrong, my buddy? Why are you so sad today? Come on. Come on. Oh, no. Oh, no, Chester. I don't know. It's a sad kitty today. I don't know what to tell you. Okay. So we're on the back side of this now. There are a few Phillips head screws that we can tackle. And as I keep going through this, we're trying to get into the optics here, the optical path, and see some of these cool lenses that this thing has to have inside it. Okay, there's one. So this is the part that the camera would have connected to. We've got those guys free, and it's a very low thread pitch connection there. So anyways, there's two. Then on the back here, we see our first hint. Let's see there. So we've got a mirror, another lens. This is the main optical path. And you can apparently flip multiple, you get my hand out of the way. You've got multiple options for what it is that you're going to look at there. Huh. Wonder if we can take this apart in such a manner that I can show that to you a little better. I'm kind of curious what this little multi-select thing is for. Quite obviously serves some purpose. That can't be all of them. That was just two. What else is holding this together? There's another one. All of these things were torqued to perfection. I tell you, this is a beautiful thing to see. Whoop. Are there any other case mount? It doesn't feel like it wants to come off yet. Let's see, let's see. There are some more Phillips we can tackle. That's always fun. This looks like it's a mirror path, like the light might bounce into it for something, but I could be wrong. Boy, oh boy, I tell you, are we having fun yet? Okay, come on. Here we go. If you would like to see more teardowns, let me know. We've got a poll going up above. If you don't want to see teardowns, let me know that too. You got to wonder what this lens has seen. Where it went, what it did. You know, it's expensive enough, it certainly could travel around the country and around the world. But I found it in Los Angeles. It's old enough, it could have been around for the Olympics back in the 80s. Who knows? Who knows? I am still going around taking apart just random screws. My goal is to get the optics free at this point. There are still a few connectors and switches and whatnot we can take a look at. But I mean, there's only so much you can talk about with a switch. So what I'm looking for is a ginormous lens. And if you're just now joining me, I've been doing this for the last hour and a half now. We have ourselves a marathon. Dismantling session. And I've yet to have an opportunity to use the smash hammer. So hopefully that's coming. There we go. That's free. This is a mechanical shroud that is protecting the connectors for the camera. And I gotta tell you, I mean, these things are dense connectors. We'll take a look at them in greater detail in a little bit. But this is the type of stuff you see in airplanes. And I just want them free. Free, I say, free. Boy, I tell you, so many screws. The bill of materials on this lens had to be, you know, a manual. It had to be a book. You've got to keep track of all the screws, all the connectors, all the wires. The wire harnesses all have to be laid out on pegboards, on, you know, beds of nails. All of this stuff has to be engineered. And all of it goes into the cost of these lenses. And you got to figure at a couple $100,000 a pop, there's not going to be too many people buying these. So you have to recoup all of your costs on a relatively low volume of manufacture. Okay, how we doing? I want that free. Okay. What else can we do here? Get that loose. Alex, did we lose you? How's the audio doing now? And how long did I lose sound for, buddy? Oh, we're getting there. Oh, Chester's a sad boy. Okay. We can probably go ahead and liberate these. Man, that is a lot of wires. Aren't you a sad kitty today? What's going on, baby? All right. Let's see if I can get a screwdriver in here. Pop a couple more screws free. Using my favorite tool, the Van pliers. I have no idea what we're going to do with 2 hours of teardown video. But we'll have 2 hours of teardown video. Oh boy, oh boy. Much better. Just a couple minutes. Okay, so I just lost it for a couple minutes. Okay. Yeah, the batteries went dead. I don't tend to record this long, Alex. We could lose them in the receiver too. I changed those right before we started, but you never know. But this is all getting recorded. There's no way we're going to make a 2-hour video out of this, so maybe we'll just cut that part. Okay, I think these are too big by a lot. Yep. All right, we're still trying to get into that optical path. We've made some progress, but not nearly enough. There's some dip switches up here that set something. I don't know quite what. Alex, it took you quite a while to reply to that question that I posed to you. You didn't wander away from my teardown, did you? That'd break my little heart, Alex. Break it right in twain. I will tell you though, Internet, this is the part where if I wasn't on live video, I would have taken a break by now. Wandered off, gotten a burger. Who knows? The world would be my oyster. Let's get to Oh. All right, Internet. What did I do with my Allen set? Here we go. It's going to be too small. Let's try this guy. Yep, that's the right guy. Just not going in. Come on. There we go. All right, I found a new set of Allen key or socket head cap screws to go after. I want those giant platter lenses. I want to see what's inside. I think you do too. But yeah, the number of engineers that had to be involved in this thing. Truly astounding. I mean, it just had to have been a huge team. And then they made different ones of these for different purposes, I'm sure. And then each year they had to make it a little better. And man, just... I got to tell you, Canon, I'm impressed. I think these are going to remove the casting, or the metal casting from the rest of the lens. Yep. Okay. But look what we got. Check this thing out. Now you can't tell this from where you're at, because you're on the internet. I get to see things you don't. Let's see if we can get this thing up there. I don't know if you can see, where is it? Right back in there. These bearings. But this thing is just smooth as anything. So, we've got the lens free. It's on some cool bearings. We're going to set that down. We're going to come back to that. That is just too neat. Okay, we're making progress. It ain't fast progress, but we're making progress. So now there's another lens in here, and it runs on probably a similar bearing system because it moves pretty smooth. So we're going to see if we can't just keep popping socket head cap screws and seeing if this thing doesn't just fall the rest of the way apart. Come on. Even this sand casting, just the engineering in that. So much of this thing is so impressive. we've made progress. And that progress is going to get rewarded by raising my blood sugar back up. Unnecessarily high, I'm sure. Okay. What is holding that in? Don't know, don't know, don't know. That's a sneaky one. Okay. All right. So we've got the focus drive motors and rotary encoders, all free. Those things spin so smoothly. And then we're just going to keep going till there's nothing left to get got. So now we've got to figure out what's holding this onto the casting. Good news is everything's getting much lighter. This lens must have been 40 pounds before. And it made some scratches in my desktop, I'm telling you. Okay, up top we've got some amount of calibration screws. I don't really know what those are, but they've been glued, which pretty good indication of don't ever remove them. So I'm taking them off. I tell you though, I would love to have met the team that did this. So much cool stuff in here. Okay. What else is left for me? No new comments. So Alex could have deserted me. I wouldn't know. Okay, so those three screws were attached to this first surface mirror. So they were part of a calibration for this mirror. They pushed on the back side of it. And the center mounting screw is on a pivot of some sort. So now the question is, how do I get into the rest of this thing? And the answer is not clear. But there are some cool things to see. So I'll tell you what I'm going to do. I am going to find another card. Because we filled up the one on the camera. and I'm going to keep digging in. I might have to go to the camera case. Excuse me for one moment. Are they not here? Oh no. Well, that is unfortunate. That is where they were supposed to be. Okay, well, we can plan B it. Is that a 1? That's a 32. That'll buy me some time. We'll go for a micro SD. And oh, that's the wrong one. Whoops. So there's our card. There is this. Power back on. Please don't be dead. It's almost dead. Okay, we need power. We're at 1%. That is no bueno. For those of you that don't speak Spanish, no bueno is the opposite of bueno. As I'm sure you've figured out by now, nothing that I'm using have I ever used this long. We need power, and we need a lot of it. So my apologies for keeping you on the hook and waiting. Fortunately, I mostly know where things are. Let's see if this USB adapter is strong enough. Oh, get in there. Is it charging? No, come on. It's not doing the charge thing. Let's see what else I can come up with. I've got a whole thingy of chargers. Probably need one of those big ones that has the color thing. There we go. USB Type-C. This'll do it. I can feel it. I tell you, Internet, the things I do for you. Okay. Charging. Let's see if it'll turn it on. It will. Will it connect? It will. Will it zoom? It will. Whoa, that didn't sound good. Let's recalibrate. Okay. We're going to have to reconnect there, but I can auto this over. All right. So where we're at, we've got this metal casting and we've got a mount plate attached to it. And the mount plate does have some electronics on it. So I want to free that. There are I don't know if you can see that, but there are socket head cap screws hidden. Hidden in access holes. So I might need to get this device off. Let's see here. Since I lost power, I have to reconnect everything. Okay, so there's a little gear of some sort. I don't even know what that is. And that gives me access, whoop, get on screen there, to this hole. Am I on screen? I don't know if I'm on screen or not. Oh, we're so close. Feels loose, looks loose. But here's one of the things I wanted to show you. There's this multi-select inside that did something, and I don't know what it did. But it's sufficiently cool that I do kind of want to show it to you, if I can get to it. I can't imagine that, let's see here. I can't imagine that these two little screws down here have anything to do with anything. But I'm going to pull them anyway, just in case. They just seem like a little flange bracket. But something over on this, yeah, they're not connected to anything. But something over on this side is holding up the works. And I don't know what that is. But this is the part that isn't coming loose. There's a connector marked extender. I don't really know what it does. But it's gotta go. So it's a little itty bitty gear train thingy. Let's see. Just taking apart the socket head caps as I see them. But we're still firmly connected. What are we saying in the comments? Do you know if that camera had a polarized filter, a UV filter? There's something down here that looks weird. That could be a UV. Typically, you put the UVs on the front. As far as polarizers go, I didn't see anything that made me think there's a polarizer in here. But again, usually where you would put the polarizer would be in front of the front lens. There we go. Got it free. Now, interestingly, places like news organizations and whatnot won't use a polarizing filter. They feel that it's altering what you would see, and therefore it's unethical to modify the image in any sort of way. I know, weird, huh? Okay, whew, that was fun. Okay, so here's what we got. Rawr, this isn't even heavy anymore. I'm still picking it up like it is. Get this over the shoulder. So there are 3 selections. There's a little spring-loaded bearing over here that kind of locks everything into position. So one kind of looks like a straight pass-through. One is like a half-mirrored surface. And the other one is some sort of optical element to do something. I don't know. And then there's a switch down here that lets the system know that it's actually locked in place. So, neat. We're getting there. We're getting there, Internet. What else do we want to take apart? Get off here. The iris control would be nice. I'd love to get this free. Let's see what we can do. And let's do it on camera 6. Thank you, by the way, anybody who's joining me in this marathon teardown. I sure don't expect anybody to stay for the full, what are we at, 2 hours now? Yeah, 2 hours. But as you come and go, leave comments, ask questions. Okay, so we're getting now to parts that are not meant to come off. as you can see there on camera 6, I can't even see camera 6. That white stuff, some sort of a paint or thread lock. Excuse me. Nope. Nope. Well, that piece is staying on. How about we try those hex heads? Spinning. So this is the little angled thing that I thought that might be the focus control. I wasn't sure. But it looks like there's a mirrored surface that bounces into that rotary part. Sorry, I'm just trying to figure out what comes apart next. We could probably get this image element out. Let's do that. Back to camera 2. Stay, little guy, stay. So this thing is on some incredible bearings, to the point where it's actually difficult for me to apply stress onto the face of the screw to turn it. It's pretty impressive. Tell you what, let's take out this ring and see if that does anything. You know, nowadays, if you were to try to do any of this, there'd be flexible circuits and everything running up and down these, inside these lenses. Sensors galore. I mean, all sorts of good stuff. Hector asks how much this camera cost when it was new. Hector, I'm not really sure, but I would expect this was in the neighborhood of, you know, I would think certainly north of, you know, $25,000 to $40,000 US. Some of these camera lenses, the current versions, go for $200,000 nowadays. But I wasn't able to find out much information on this one. They certainly go for more than the $50 I paid for this. I don't know if you guys can pick it up on my microphone or not, but every time I move this, more screws just fall to the ground. I'm making a mess. Come on. Move, you booger. This one protrudes through the surface. No, just stripping it. Well, my oh my. Back to plan A. I am trying to keep an eye on the chat messages, so if you do have any as we go through, please do ask. Happy to try to have a conversation with you. Makes this job a little less lonesome. Yeah, it was expensive, Hector. Very expensive. But like I said, luckily I paid $50 for it. I got it at Apex Electronics. It's a surplus store in Burbank, California. All right, we got another cool lens element. Woo! Ha ha ha, tiny-headed Mark. That's kind of fun. Oh, okay. There's another lens deep in here. Let's get this back on the shoulder again. So that when that lens moved back, the other one would move forward. Cool, huh? Okay. We're bouncing screws all over the place here. I have an issue in that that screw is permanently damaged now. I wasn't able to remove it. So I'm going to have to get noisy. If you're ever taking apart a device and you run into a stainless screw, these aren't stainless, these are soft steel. But about the only way you can get them is with cobalt bits. So what would this camera have been used for? That's a great question, Alex. This could have been anything with this zoom range. Probably, you know, you might see it at a sporting event, tracking NASCARs, or even at the Olympics, tracking athletes. But anyhow, the idea is to drill through and remove the head of the screw so it can no longer hold whatever it was holding. And cobalt does a terrific job. They are more expensive, but man, they just go right through stuff. I might need to go a little deeper, in fact. That was deeper. That went through. Yep, no more texts for now. Okay. So now how do we get that out? I don't know. Okay, we're just going to keep taking stuff apart. Till eventually it makes sense. But yeah, with the zoom range on this lens from, you know, I forget what it was like 6 to 380, I think, or something like that. You know, you could see things that are kilometers away. Really absolutely stunning difference. And the cool thing is, with the way that these lens elements are constructed, it'll maintain focus that whole time. So as it's going around and doing its thing, you know, zooming in and zooming out, the subject will stay in focus. Okay. They have these screws in here painted over, and I can't see what the head type is. No bueno. Oh, you know what? This might be threaded on here. I don't know. But if that's the case, I can pop that whole assembly off. Oh, I don't think so. Looks like it might be press fit. Let's see. Let's twist it a couple more times. It doesn't feel like it's threaded. It feels like it's just spinning, which indicates that it was just pushed on. Yeah, it was press fit on. That's okay. I am strong like bull. Get that thing off. Do we have new news? Are newer versions of this camera smaller, bigger, same size? That's a great question, Alex. Roughly the same size. You can't get around the physics of it. To get as much light in as possible, you need a big lens on the front of this thing. You can't get to, you know, if you're working in the dark or someplace that doesn't have a whole lot of light, you need a big lens to capture as much as possible. There's just no getting around that. They do cheat to some extent. Nowadays, you can do a lot of stuff with digital and whatnot, but all right, so here's what we've got. This is that little spinny lens assembly. Thrust bearing. And, and we're stuck. No, maybe we're not. These things are built so well, it's actually pretty hard to see the bolt heads because they sit flush. I mean, they did a great job. So we're going to try a 7/64 here. Too small. Move up to a 3. Still too small. Man, I'm just batting 1,000 here. Let's try a 4. That's way too big. Split the difference. 9/64. Maybe. Can't really tell what that's doing. Hi, Chester. What is that doing? Okay, not much. There are some really small screws in the back face of this. I can't imagine that they're structural, just based on the head size, but maybe I'm wrong. Like I said, when in doubt, just start unscrewing things. These things feel really tight, like they don't want to move. Okay. Nope. The trouble that I'm having now is some of these screws don't want to move. You know, they've been in place for quite a while. And all I'm doing is just destroying the threads, trying to move them. There are some tricks I can try. I just don't have the materials available to me now. So once I figure out what these do, what I'll probably end up doing is just drilling through them, rather than putting some brake fluid on them, or not brake fluid, but some brake-free oil or anything. Okay, do we have other questions? Sí, señores, no es bueno, sí. Héctor hablas español. Más bueno de mí. Solo hablo un poquito de español. So Hector, how did you find our stream today? And welcome. This is a long stream to be involved in. Thank you for hanging around as long as you have. Come on. See, this feels like this. So what I'm messing with now is what looks like a piece of milled aluminum on the back of a sand casting. Come on, Chester. What are we doing, baby? Come here. Oh, come here, buddy. Let's see. Oh, there we go. Get you back up on the desk there. So I'm trying to separate this aluminum piece from this sand casting below. Okay. We are going to drill again. And since we're making noise, I hope you don't mind me indulging in additional sugar. Mama said knock you out. What's up? I meant to do that. So those tiny little screws were what was holding everything together. Oh, we can see something new. We can see the iris. So the smaller it is, the less light that gets through, but it greatly increases your depth of field. When it's wide open, the light can spread out and you can get things that are out of focus easier. That's your trade-off. Maybe if I get a chance, I'll do a graphic for you. Okay. Now, to get the rest of the way apart is tricky. We've got to figure out where the align... Sorry, there we go. Okay. When it's all the way retracted. So, this lens now has these screws that are hidden on the sides. And once we remove those, we can actually pull apart that final lens assembly. But, you know what they say, when in doubt, camera 6. Let's see, did we switch? The movie I recorded is big. I know. Ah. Okay, we need... Look at this mess, people. Look what you've put me to. We need our screwdriver. Anybody know where I left it? I hid it from myself. Yes, I think it is time for Dr. Pepper. Yep, I got to keep going. Alex, you might know now why I waited to do this one. So now we've got these tiny, tiny screws, but the screw heads are very narrow. So these go in guides that control the rate of, well, not really the rate of motion, but the range of motion. They are internal cams, and they're engineered in such a way that they move the two lenses in here so that when one lens moves forward, the other moves back. And that's how it maintains focus. So by removing the screws, we're essentially eliminating the cams, and that should allow that internal lens assembly to fall out of the lens. I think I got them all. I'm not sure. It doesn't fit in there at all. Let's see. Let me save one of these for you. So right now I'm knocking off the, you know, these things are actually little baby bearings. I don't know if you can see that or not. But these cam rollers, it looks like it's like a brass or a bronzed. And I hope once all those are off, that this thing will be ready to disassemble itself, unless I missed some. Sometimes you have to rotate them multiple directions. You know, there's more than one coincident point. Well, it sure doesn't move smooth now. I broke it. Looks like oh no. Each one's got two bearings that have to go. Oh, great. That's gonna be difficult. There are multiple points of coincidence, but I don't know how to keep getting in here. I might be missing something, so let's go digging. I found more screws. One thing that does concern me is I do see spots for spanner wrenches, and I don't have any of those. So I'm hoping that the screws that I do see, oh man. I am sure missing something. There's a screw. There's two screws. What do these things do? Be nice to get that out of the way. I don't know if that's possible. Is that a split? It is. It's a split ring out of a piece of brass shim stock. I've never seen that. Usually they're stainless. So they weren't worried about that coming off. Come on. Nope. No, come on. There, I got that one. Little noise coming your way, peeps. All right, we just liberated the iris. Where did Mark go? There he is. Where did Mark go? There he is. I'm getting tired. Screwdriver's over by the thingy. Thank you, Alex. All right. If we're down to spanners, I'm out of luck, but I don't think we are. I gotta feel like there's something I'm missing. But what it is that I'm missing, I don't know. Time for the flashlight again. If we can get that a little higher, okay, that should return sound to us. But what did we lose? You guys saw me take this one apart, and you saw me do upside down mark, right? What? There's upside down mark. Woohoo! That's fun. Did you see? Where did Mark go? There he is. Where did Mark go? There he is. You saw that, right? I don't want you to miss that one. But here's the important message. Multiple sets of batteries later, we're done. We got it. We're done. Now, or we could do it another time. It's up to you, Internet. Now, what we want to know, we did all this so we could look at the circuitry and the circuit boards. Those are out. The lens is taken apart. What do you say? We sit down and we look at a few. Just below the lens. Where's, yes, mark is just below the lens. That's right. All right. It's going to take me a second to clear off the workbench to a degree that we can actually inspect that stuff. We can stop recording there. I wanted to look at a harness. Yes, baby, come here. Oh, Chester's just all out of sorts today. Poor little guy. Don't need any of that. Might need these. Okay. Hi, Internet. Mark. This thing is massive. Massive, I say. But man, does it move so beautifully smooth. I don't even know how to tell you. I wish you could feel that. It's as amazing as it is heavy. More lenses. There's a lot of optical elements. Pretty amazing that somebody sat down and figured out how to do all that before computers, before CAD programs. Somebody had to put all that on an optics bench. Okay. So here's what we've got. This lens actually had an issue that I wasn't responsible for. This board edge connector is broken, right? So the board that went in there, is that the heater? The heater board would not have been functional, or at least not safely. So the board could have still functioned in that, but if you were doing, Winter Olympics and whatnot, you might have had some issues. But the first thing I wanted to look at, before we look at these boards, is this beautifully done wire harness. The wrappings might be a little tight in some spots, but everything comes off. The 90 degrees take off in the middle. There's a little bit of stress relief. The wrappings are a tiny bit tight, but they're fine. They're not cutting into the insulation at all. I mean, it is just slick and clean. You can trace the wires. They were all kept nice and straight. It's just really well done. I was impressed. And these connectors, forget it. So you've got, a bunch of signal and what I assume are, high current or high voltage based on the level of insulation on the front and back of these things. They've got to be high voltage. It was just cool. And then the other thing, you just don't see boards like this anymore. You haven't seen boards like this since the 80s. So what am I looking at? Let's look at the back side of a few of these. 2-layer boards, because that's what the technology could do at the time. These tracks aren't on, really much of a grid. They are kind of gridded out there, but plenty of them are at weird angles. And that's totally okay. The reason that we have boards at 90, traces meeting at 90-degree angles and whatnot today is the first CAD programs, that's all they could do. They could only lay out stuff on grids, So somebody would sit there and they would, you know, hand trace this stuff. Or the next step, they would lay it out on big sheets of acetate at scale and then, you know, project it down. These are, I don't know what these are. I don't recognize those ICs. But these are cool. Board edge connectors, you could, you know, notch them out if you're doing a high voltage for your creepage and clearance. Test switches, so you could test each one of these boards separately. And this is all just, I mean, this is not a complicated circuit. Resistors, diodes, you know, a variable resistor, some transistors. This is, I mean, this is a board an introductory engineering student could do. This one's got some logic to it, but still not that bad. It is certainly complicated, and they did a good job of trying to keep everything nice and organized. You know, you can see the circuit blocks, so you're not routing traces all over the place. Looks like this is a later board, except they've got a bodge wire on there. Somebody made a boo-boo, and then a bodge capacitor. Another bodge wire. So some people made some boo-boos. It happens. Anyhow, internet. Where am I? No, where's Mark? There we go. Anyways, internet, it has been an absolute blast today. We're almost three hours in, and I've got an upset cat that I guess, you know, maybe he can see the bottom of his food bowl. I'm not sure. But I'm going to go grab lunch, and I want to thank everybody who joined me today. That was a marathon. We'll try to get that cut down into something a little more useful to you. Have a great rest of your day. We'll see you later. Bye.